Welcome to My Safety Training Online presents Machine Guarding Safety. The basic hazards involved in machinery, including the point of operation and power transmission devices, will be discussed, along with introducing control measures to effective machine guarding principles and methods, various hazards of mechanical motion and actions, and we'll present some techniques for protecting workers from these hazards. Crushed hands and arms, severed fingers, blindness. They head the list of possible machine-related injuries as long as is horrifying. There seem to be many hazards created by moving machine parts, as there are types of machines. Safeguards are essentially for protecting workers from needless and preventable injuries. Introduction to machine guarding safety. A good rule to remember is any machine part, function, or process which may cause an injury must be safeguarded. Where the operation of a machine or contact with it can injure an operator or others in the vicinity, the hazards must be either eliminated or controlled. This presentation will present an overview of various hazards of mechanical motion and different types of requirements that are effective for safeguards, and a brief discussion of training guidelines. The basic rule of machine guarding is if it moves, it merits your attention and should be guarded. Slide 8, the purpose of machine guarding is to protect against point of operation, in-running nip points, rotating parts, flying chips, and sparks. Although some OSHA standards provide certain machine guarding requirements, Subpart O provides general guarding requirements, in addition to specific requirements for woodworking machinery, abrasive wheel machinery, mechanical power presses, and power transmission devices. Machine guarding principles call for dangerous moving parts in three basic areas requiring safeguarding. The number one area is the point of operation, the point where work is performed, such as cutting, shaping, boring, forming, grinding, turning, shearing, punching, bending, and drilling. Number 3 guarding principle is other moving parts. All parts of the machinery which move while the machine is working. Examples of this would be reciprocating parts, rotating parts, transverse feeding mechanisms. Part 2, hazards of mechanical machinery discussion. A wide variety of mechanical motions and actions may present hazards to the worker. These can include rotating members, reciprocating arms, moving belts, meshing gears, cutting teeth, and any parts. These different types of hazardous mechanical motions and actions are basic in varying combinations in nearly all machines. Slide 15. Machine guarding, hazardous machine motions. This would include flywheels, shafts, pulleys, gears, sprockets, couplings, fans, and clutches. It would include in-running nip point hazards. parts which rotate in the opposite direction, as well as rotating and fixed parts. Hazardous mechanical motions and actions include motions such as rotating, reciprocating, and transverse. A rotating motion can be dangerous. Even smooth, slowly rotating shafts can grip clothing. Here you can see some illustrations of nip points on the graphics. A reciprocating motion will be back and forth, up and down. It may cause someone to be struck by or caught between moving and stationary parts. Examples of this would be scissor lifts, shaker screens, feeder tables, knife sharpeners, slicers, feeding and ejection parts, etc. Here we can see an example of transverse motion, where a straight and continuous line is such as a conveyor belt or a lengthy belt, where a worker may be struck by or caught in a pinch by a shear point or by a moving part. Transverse motions involves cutting, shearing, bending, and punching. Here we can see depicted all four of those. Part 3, Methods of Controlling Machine Hazards. There are many types of ways to safeguard machines. The type of operation, the size and shape of the stock, the method of handling, the physical layout of the work area, the type of material, and production requirements or limitations will help determine the appropriate safeguarding method for individual machines. As a general rule, power transmission apparatus is best protected by fixed guards and enclosing the danger area. Other safeguarding strategies may include using location and/or distance, as well as feeding and ejection methods. Here we can see some miscellaneous aids which can help reduce the exposure by using awareness barriers, protective shields, hand feeding or holding tools, as well as anti-restart devices. Part 4, Effective Guarding of Machine Parts. Machine guarding, effective machine guarding methods. They must prevent contact to the machine hazard, plus they must be around, over, through, and under the guard. They must be designed and constructed as to prevent the operator from having any part of his or her body in the danger zone during the operating cycle. Guards must not present a hazard in themselves or create interference. They must not allow objects to fall into moving parts, and the guard should allow safe maintenance and lubrication of the machine. The last criteria for erecting an effective machine guarding mechanism is to fix it to the machine wherever it's possible, and it should remain secure. It must conform with other appropriate standards put out by the American National Standard Institute, as well as the manufacturer's specifications. Guards are a physical barrier which prevent access to danger zones. The types of effective guards include the following: fixed guards, which are a permanent part of the machine. A fixed guard will be a permanent part of the machine and not dependent upon moving parts to perform its intended function. It should be constructed of sheet metal, screen, a wire, cloth, bars, plastic, or other substantial material. It is usually preferable to other types because of its relative simplicity and permanence. Interlocking guards. When they are opened or removed, the tripping mechanism and/or power will automatically shut off and disengage. The machine cannot cycle or be started until the guard is back in place. It uses electrical, mechanical, hydraulic, or pneumatic power and replacing the guard should not automatically restart the machine. Remember, interlocking guards can be bypassed. Adjustable guards will allow flexibility in accommodating various sizes of stock. Self-adjusting guards are determined by the movement of the stock. The guard is pushed away, is introduced, and the opening is only large enough to admit the stock. Guards will return to the rest position after the stock passes through. A safety device controls access to danger areas and may perform several functions. It may stop the machine if a hand or any part of the body is inadvertently placed in a danger zone. It may restrain or withdraw an operator's hands from the danger area during the operation. Machine guarding with devices that control the hazard will require the operator to use both hands on the machine controls. They will provide a barrier which is synchronized with the operating cycle of the machine in order to prevent the entry into the danger zone during the hazardous part of the cycle. Photoelectric guarding uses a system of light sources and controls which can interrupt the machine's operating cycle. Radio frequency uses a radio beam that is part of the machine control circuit. When the capacitance field is broken, the machine will stop or will not be activated. Electromechanical types of guards have a probe or contact bar which descends to a predetermined distance when the operator initiates the machine cycle. If there is an obstruction preventing it from descending in a full predetermined distance, the control circuit does. Machine guarding pullback devices utilize a series of cables attached to the operator's hands, wrists, and/or arms. This type of device is primarily used on machines with a stroking action. Slack is taken up during the down cycle, pulling the operator's hands from the point of operation if still there. When the slide ram is up between cycles, the operator is allowed to access the point of operation. Machine guarding restraint devices call for restraint holdout devices utilizing cables or straps that are attached to an operator's hands at a fixed point. The cables or straps must be adjusted to let the operator's hands travel to within the predetermined area. Consequently, hand feeding tools are often necessary if the operation involves placing the material into a danger zone. Safety trip controls provide for a quick means of deactivating the machine in an emergency situation. A pressure-sensitive bar is strategically placed and it will deactivate the machine when depressed. The safety trip wire cables may also be located around the perimeter or near the danger zone. Machine guarding two-hand controls require constant concurrent pressure by the operator to activate the machine. With this type of device, the operator's hands are required to be at a safe distance on the control buttons, or a safe distance from the danger area. A gate is a movable barrier which protects the operator at the point of operation before the machine cycle can be started. They are usually designed to operate with each machine cycle. Type A remains closed during the entire cycle, whereas Type B remains closed only during the downstroke situations. Other methods to consider when guarding a location are: can it be still accessed even with great effort? Can pieces and parts break and fall onto someone or something? Are sparks or other flying debris being produced from the equipment? OSHA still has a 7-foot rule for fan blades and power transmission devices. The size of the stock and controls positioning for safe distance are other factors to consider. Here we can see the transparent enclosure guard, the stock feed roll, the danger area, the completed work area, the scrap material area, the power press with automatic feed area. Automatic feeding and ejection are also methods of controlling the hazard. The operator's involvement is not necessary after the machine is set up in both situations. The semi-automatic feeding rejection mechanism will manually feed without reaching into the point of operation or other danger zones. Here you can see the plunge handle, the ejector leg, the stock, the magazine. The bottom depiction shows the plunger handle, the ejector leg, and the semi-automatic ejection mechanism. Here we can see machine guarding by robots, machines that load and unload stock, assemble parts, transfer objects, perform other tasks otherwise done by the operator. Robot concerns include being struck by robotic arms and other mechanisms within or near its working envelope. The most common injuries of being struck by an end effectuator or claw in the end, and being pinned between the end effectuator and the stationary object. It is also possible for malfunctions and missteps can surprise nearby workers. This particular device is covered by ANSI 15.06/99. Miscellaneous aids do not give the complete protection from machine hazards, but can assist in moving stock and deflecting minor chips or providing awareness to the operator. Examples include awareness barriers, ropes, shields, holding tools, push sticks, or blocks. These aids do not replace the need for personal protective equipment or guarding. Anti-restart devices are required if the machinery can automatically restart when the power is restored, such as after a power failure. Machine guarding includes metal turning machines such as lathes, grinders, drills, gear cutters, to require chip and coolant shields and chuck shields. A spring-loaded chuck wrench should always be used on metal lathes. Automatic cutting and turning machines require point-of-operation guarding. Examples of this are plexiglass shields on abrasive wheel grinders, which do not substitute the requirement for eye face protection, or a tongue guard if the distance from the safety guard or top periphery zone exceeds 1/4 inch. Plus, they can get in the way and are often broken and dirty, creating hazards in themselves. Part 5, Machine Guarding Safety Training Requirements. Safety training requirements will include a discussion of hazardous exposures and the control measures, hazardous motions, hazardous actions, the potential for flying and ejected material. Of course, when we're safety training, we'll need to include fire and combustion potential, the appropriate personal protective equipment and clothing, health hazards, air quality, noise and vibration, as well as metalworking fluids. Your supervisor should also include equipment-specific training, doing hands-on with proper operation of the safeguards, what the limitations of those safeguards are, as well as what maintenance and care procedures will be followed. Retraining. If retraining is required, training and relevant retraining must be provided for new operators and maintenance and setup employees. Also, retraining affects employees when a new or altered safeguard are used and when the employee is assigned to a new machine or operation whenever worker deficiencies are discovered. Machine guarding safety summary. Any part or machine part or function or process which may cause injury must be safeguarded. Dangerous parts fall into 3 basic areas which require safeguarding: power transmission apparatus, other moving parts, and the point of operation. Lastly, there are many ways to safeguard machines: the type of operation, the size or shape of the stock, the method of handling, as well as a number of other factors which will contribute to the safeguarding of machines. Thanks for participating.